I'm on the bottom of page 15, and we have 4 terms that we need to define so that we can start looking at trigonometry. The trigonometric ratios. We've already looked at some trigonometry with right triangles, but we're going to look at the ratios that go with trigonometry. So first of all, let's define a ratio. A ratio is a comparison between two quantities. And let me give you an example. A very common one is miles per hour. That's the speed ratio. And I'm writing ratio again. Miles per hour. You can write it this way in math terms. Instead of the word per, you can use the colon. You can write it miles to hours. That's a comparison. But the way that we will do it most often is in fraction form. So we will write one of the units on top and the second unit on the bottom. Miles per hour. And that is the definition of a ratio. All right. With respect to trigonometry, the word opposites. And let me just say, in trigonometry, and let's stop right there. Trigonometry. Okay. Trig means triangle. Metry means measure. So when you're measuring triangles, the opposite is the leg. Now, where have you seen that word before recently? The leg of the right triangle that is across from theta. You say, well, Miss Amanda, what in the world is theta? So we're going to go look at that and then come back to this definition. So go to page 16, and there's theta. Let's get this definition. Theta looks like a 0 with a line across it. It is a Greek letter. It's not constant. There's no value assigned to it. It can be anything. But it's a Greek letter used to name a certain angle in a trigonometry problem. There are much better definitions, but I want this to be as simple as I can make it. And I'm going to show you what I mean. So let's draw ourselves a right triangle and label the right angle. That's your 90 degree. And right in here, let me zoom in. I want you to color this one or shade it even with your pencil. Just shade it in. And let's name it theta. Okay, that's pronounced theta. It's a Greek letter used to name a certain angle in a trigonometry problem. And by the time we get finished with trigonometry, you will be very familiar with theta. Okay, let's go back to opposite and finish this definition. We finished the definition, but draw yourself a right triangle. And put in your right angle and put in theta. Over here is little theta. Theta can help you do wonders with math. So here's theta. And with these kinds of problems, everything revolves around theta. Theta is the center of the universe with these kinds of problems. The side across from theta. So if you're standing on theta and you're looking across the triangle, you're going to see this one, this blue one right here. That is opposite. And that's the leg that we're talking about. So go ahead and name that one opposite. It is across from theta. Doesn't matter about the right angle unless that's theta. You find theta, you go across from it that way, and there's opposite. So let's look at adjacent. If you're talking about trigonometry, and I used to see that when I was learning to spell it. I didn't learn to spell well, so I had these weird things. But I saw it as trigonometry, because when I first looked at it, I thought, oh no. But you'll do fine. We're going to take it a step at a time, and you'll be doing these problems before you know it. But in trigonometry, this is the leg not the hypotenuse. It's the leg of the right triangle. You got to have a hypotenuse, but adjacent is not your hypotenuse. It is the leg of the right triangle that is adjoining theta. It's hooked to theta. Think of an adjoining room in your house. They're rooms that share a wall. So this is the leg of the triangle that shares theta. So let's draw a right triangle, and I'm going to keep them going the same way for right now because I don't want to confuse you with changing up the direction. So here is the right triangle, or the right angle. Here's little theta, or big theta, whatever theta happens to be. Let's shade her in there. The adjoining side, the adjoining leg, it can't be a hypotenuse. It's going to be the adjoining leg is called adjacent because at this corner, that adjacent is touching theta. Okay? And these pieces are critical to doing trig. You have to know opposite, adjacent, hypotenuse, which you already know, and theta. Once you learn those and you know those, you can do any trig problem that you're going to come across. So trust me, it will get better. Right now, I know this is new. This may be something you've never heard of in math. But once you learn it, it's going to help you do that power triangle a lot more easily. So come back for the next one. Let me be sure that I got all of, yes. We will look at real power, that's power triangles. So right now we're going to stop and do some trig, and then we'll come back to these terms.